Alright guys, so now we're going to determine whether graphs are functions, and we have an easy test that allows us to determine if a graph is a function, and that is called the vertical line test. So what you do is you take a vertical line, so you can take a pencil, a pen, just anything that could represent a vertical line. I'm going to do mine vertically like this with just a red line because I have the advantage of having this screen here. And if multiple points on your graph fall in the same vertical line, then it is not a function. Meaning if two or more points hit this vertical line as I drag it across the graph, then it would not be a function. For example, number 1, dragging it across the graph, well, it only hits one point at that point. It just hits 1 point there, 1 point there, 1 point there, but uh-oh, it hits 2 points at that vertical line there. This would be considered not a function. And it makes sense because if I were to actually write down these ordered pairs, this first point here would be the point 5, 4. And this next point here would be the point 5, -3. And so we do have the same two x values being mapped with two different y values, which we know, but we should know by now that that is considered not a function. So this is no. And then it does say to explain. Now we can be specific by saying that this just fails the vertical line test. That's specific enough for me for the graphs. All right, so number 2, I'm going to take my same vertical line and I'm going to drag it across this graph. So far it is not hitting more than 1 point, and it looks like it made it without hitting more than 1 point, so this is yes. And then your explanation would just be that it passes the vertical line test. All right, number 3, same thing. I'm going to take my vertical line and drag it across. Oops, well, it's hitting more than, or it's hitting 2 points at every single point on this graph. So this is not a function. And we can just say right away that it fails the vertical line test. All right, going down to number 4. Number 4, we haven't seen one like this before. Now the open dots mean that those are actually not points on the graph. So for example, when I drag my vertical line across this graph, at this point right here, it looks like it hits 2 points at once. However, since this point down here is an open circle, then it's not technically hitting that point, or that point's technically not on the graph. So, in fact, this constitutes as us passing the vertical line test. Same thing at this point. Because of that open dot, that's actually not a point on the graph. And same thing for the rest of this graph. It looks like it passes the vertical line test. So yes, and then vertical line test. Oops. All right, looking at number 5. It's not hitting 2 points at once. So this is a function. And it passes the vertical line test. So number 6, it looks like that this is a vertical line at this point here, but technically, so a U-shaped graph is called a parabola. And parabolas tend to get a little bit skinnier up at the top, meaning it technically is still opening up and widening and not falling in a vertical line. So this one's a little tricky because it looks like right there it hits 2 points, but technically it's not hitting 2 points because it's a very minuscule amount of change between this point here and this point here. Okay, So there is still a change there. You just need to know that these U-shaped graphs up at the top, they're not actually vertical lines there. So just something that you need to recognize when dealing with functions. So yes, this is a function. It does pass the vertical line test. All right, moving on to number 7 and 8. 7, now with number 7, this is passing the vertical line test. So yes. And then number 8, this oval graph, nope, it's hitting 2 points at every single point on that graph. So this would be no. It fails the vertical line test. All right, so you have probably guessed it. We are now going to do the domain and range for each of these graphs. However, with the domain and range, we need to learn something called interval notation. And that is for graphs and equations. We're not going to actually find domain and range from equations, but for graphs, we want to use interval notation. So I will explain interval notation, and I will explain this up here once we get into it. But if we look at number 9, whenever you have a graph that has just sporadic points on the graph, then technically this is kind of like a relation. So for number 9, we're not doing interval notation. Instead, we are going to do this set notation here, where we do the set of, and now we find all the x values. So I'm going to start from least to greatest. So I'm going to start at my leftmost point. This is the x value of -6. Then my rightmost, or keep going on the leftmost point. So then I have an x value of -3. This point here is an x value of -1. This point here is an x value of 2. And these 2 points here are x values of 5. Now you are more than welcome, oh sorry, that shouldn't be a parentheses, that should be closing this set. You are more than welcome to write out these ordered pairs. So this ordered pair here is -6, -2. And this ordered pair here is -3, 3. And then you can write down the x and y values, or you can do what I just did to find the domain, and then to find the range for this one, we start at our bottommost point, which is this point here, and that has a y value of -3. Then this point here has a y value of -2. Then this point here has a y value of 0. This point here has a y value of 2. This point here has a y value of 3. And this point here has a y value of 4. So you are more than welcome to just do it like that. But when you have just a graph with a bunch of sporadic points, you are still going to write your domain and range exactly like we do for relations and tables, because these are all the possible x values, -6, -3, -1, and so forth. But on number 10, it's different, because the possible x values for this one could be this point here, which is an x value of -4. Could be this point here, which is an x value of -3.5, or -3.1, or -3.2. So it would take our entire life if we just listed out all the possible x values in set form, set notation form. So there's where interval notation comes into play. Interval notation, basically you're giving a range of the possible x and y values. Well, domain, we want the leftmost point and the rightmost point on the graph. Well, since in number 10 we have arrows on the end, the leftmost point is actually never ending. It's never going to stop. So that's going towards -infinity. And since there's an arrow on this other end, that's never going to stop, and it's going to keep going as wide as +infinity. So in interval notation, we use open circles when the graph does not have a definite end. So when there's arrows on the graph, we are going to use the parentheses. So I'm going to say that my domain can be anything in between negative infinity and infinity. And the reason why I use the parentheses is because there's no definite end. It's going to keep going past negative infinity and infinity. And then for my range here, we want the lowest point and the highest point. Well, since there's an arrow going down, that's going to go down and down forever. So my lowest point would be negative infinity. And since this arrow's pointing up, that's also going to go up and up and up forever. So it's going to go all the way up to infinity. All right, number 11 is different because my domain, my leftmost point, and you might want to draw, I'm going to call these my bounds, my boundary lines. So these red vertical lines are going to represent my leftmost point and my rightmost point. So my leftmost point on the graph has an x value of -4, and my rightmost point on the graph has a y value of, has an x value of 4. And since these are closed dots on my graph right here, that means x can be -4 and x can be 4. So we use these this bracket when we have closed dots on a graph or when your graph does have a definite end. So I'm going to say that x can be anything in between -4 and 4. And I'm going to close that off with the brackets. Now your range is the lowest point on your graph, which is this point here, which has a y value of -3, and the highest point on your graph, which is this point here, which has a y value of +3. Since those are closed circles on the graph, we're going to use the brackets, and that means y can be anywhere between -3 and +3. And we always write the lowest number first. All right, looking at number 12, we're going to save number 12. Number 12 is a little more complicated. Looking at number 13, remember when you have sporadic points on your graph, you're just going to write your domain and range in set notation. So my domain is going to be, my leftmost point is this one here, and that has an x value of -4. And my next leftmost point has an x value of -3, then -1, then 0, and then an x value of 2. So that's my domain. Now my range, looking at my lowest point first, my lowest point is a y value of -4 and -2. Then both of these have a y value of 2, so we just write that 2 once, and then a y value of 4. That's my domain and range for number 13. All right, number 14 now. Remember I said that this graph technically is still growing and widening. So if it's still widening from left to right and it has the arrows, it's going to span all the way to the left and all the way to the right. So it's going to go from -infinity to infinity. My range is my lowest point, which in this case is the y value of -4, and it can be -4, so I'm going to use a bracket and write -4. But then my highest point, these arrows are going up, which means it's going to go up and up forever, so it's going to go all the way to infinity. All right, number 15. Since my arrows are going left and right here, that means it's going to grow wide and wide forever and ever. So my domain goes from -infinity to infinity. Whereas my range, my lowest point, these arrows continue to go down forever, so my lowest point would be -infinity. But my highest point on the graph is 4. And it can be 4, so I use a bracket. And then lastly, number 16, my domain is anywhere from 1. My leftmost point is 1. My rightmost point is the x value of 4. So it can be anywhere in between 1 and 4. And for the range, my bottommost point is -4. My topmost point is 4. And since it can be that, then you use brackets. We actually aren't going to do 12 because it's really complicated.